Hey guys, today we are talking about stoichiometry. All right. It's a really weird name, but it's a big subject in chemistry. Okay. So again, this is called stoichiometry. Stoichiometry. Say it to yourself if you need to. All right. So what is this funny word? It's the study of quantitative relationships. Remember that quantitative is talking about numbers, values between the amount of reactants used and products formed in a chemical reaction. Okay, so remember we have reactants on the left side, we have products on the right side, and we have an arrow that separates them. So it's how much that we start with on the left side can create how much on the right side. That's what stoichiometry is talking about. All right, so here's an explanation on that. Suppose that you have a cookie recipe that calls for 2 cups of sugar and say that it makes 18 cookies. But you only have 1 cup of sugar. So how many cookies can you make? 9. Okay. Um, yeah, 2 cups of sugar makes 18 cookies, but you only have one. So therefore, you can only make 9 cookies. That's stoichiometry. All right, so you can see that stoichiometry deals with recipes. And the chemical equation is the recipe for the chemical reaction. Okay. Yeah, so I'm going to make sure that you have time to fill in the blanks. A chemical equation is the recipe for the chemical reaction. When we do chemical reactions, we need a balanced chemical reaction. All right, so here we have the balanced chemical reaction of making water. It takes 2 molecules of hydrogen gas, 1 molecule of oxygen gas to make 2 molecules of water. Okay, so that's what this is saying. Right? Again, it has to be a balanced equation. Right, so what does this mean? It means that it takes 2 molecules of hydrogen and 1 molecule of oxygen to make 2 molecules of water. So the coefficients of a chemical equation tells us how many molecules of each chemical are involved in the reaction. Right? Remember, coefficient are these big numbers, and if there's not a big number in front, we assume that it's 1. All right, so go ahead and start writing down these blanks. All right, it says if an equation tells me how many representative particles are involved in a reaction, and a mole is the same number of representative particles for every substance, then the coefficients also tell me how many moles of each chemical are required for the reaction. This is the basis of stoichiometry. And again, giving y'all a second to catch up on writing if you need to. All right, so stoichiometry is a way of knowing how much reactant is needed to make a certain amount of product based on the ratios of moles of reactants and products. So in order to do stoichiometry, we have to have a mole ratio. Right, so now I'm going to switch my screen. New share. I'm going to jump here. Okay, so here's the notes that you have so far. All right, if you've missed any blanks, pause and fill in what you need to. All right, this is where we left off at. What's a mole ratio? Okay, a mole ratio is a ratio of moles of one substance to the moles of another substance in a chemical reaction. Okay, so when you have your equation, okay, your balanced equation, all right, then this is when we look at the coefficients. So here it's asking for the mole ratio of hydrogen to water. Okay, so when we look at hydrogen up here, there's a 2 in front of it, so we're going to say 2 moles of hydrogen, and because it's a ratio, we're going to write it kind of like a fraction for every, and see how water also has the coefficient 2 in front of it, so for every 2 moles of water. Right, so this is what a mole ratio looks like. Right, so here it's asking for the mole ratio of oxygen to hydrogen. So when we look at oxygen, is there a number in front of it? Mm-mm. So what I say to do if there's no number? 1. Okay, so we're going to say we have 1 mole of oxygen, and then still a 2 in front of hydrogen. So for every 2 moles of hydrogen. Okay, I'm going to explain more on the mole ratio when we get to this next part. So bear with me a little bit longer. Let's do an example problem together. Okay, it says if I have 36.95 grams of hydrogen, then how many grams of water will be produced? Okay, so the question is saying 36.95 grams of hydrogen is equal to how many grams of water? Right? What I'm going to do is I'm going to work this problem out first, and then I'm going to show you the steps or we'll write down the steps that we did together. Okay, so just like when we worked out moles, you're always going to start with what you're given. Okay, so we're given 36.95 grams of hydrogen. I'm going to draw a really long train track because we're about to do some really long dimensional analysis. Okay, but this is stuff that you've been doing with moles. We're just adding to it. All right, so if we have 36.95 grams of hydrogen, I need to figure out how many moles of hydrogen that is. So my first step is going to be solve or convert to moles. All right, so if I'm converting to moles, I'm going to have 1 mole of hydrogen on top. All right, and then I need to find the molar mass of 2 hydrogens and write that right here. So when you look at your periodic table, hydrogen has a mass of 1.008, and there's 2 of them. So the molar mass for hydrogen is 2.016 grams of hydrogen. Okay, so this right here is the first step. Thank you. Okay, so we're going to convert to moles. All right, so now if I were to solve this problem, it would tell me how many moles of hydrogen that I have. It's a one-step mole problem. Okay, but I'm trying to figure out how many grams of water that I have. I can't just go from talking about hydrogen to talking about water in the same breath. That'd be like me talking to you in English, but expecting you to understand, or that'd be like me talking to you in, I don't know, French, and expecting you to understand exactly what I'm saying, even though most of you guys have no background in French. Okay, so we need a translator to go from talking French to talking English so you know what I'm saying. Okay, that's where the mole ratio step comes in. Okay, so this next step, step 2, is going to be the mole ratio. All right, again, this is my translator step. It's going from talking about the language of hydrogen to talking about the language of water. All right, so for the mole ratio, you're always going to do what you're looking for on top over what you were given. Okay, so this is moles looking for over moles given. All right, so what that means is we're looking for water. Okay, again, we're looking for water. So we're going to have moles of water on top. And we were given hydrogen, so we're going to have moles of hydrogen on bottom. All right, looking for hot water given hydrogen. All right. Now, this is the only step where you will have a number other than 1 with moles. Okay. So we're going to look at our balanced equation, which is up here. Okay. We have 2 moles of hydrogen for every 2 moles of water. So this ratio is a 2 to 2 ratio. Okay, this is when we use the coefficient. All right, again, this equation is helping me to translate from reactants to products. Okay, so that's step 2. 1, we converted to moles. 2, we did the mole ratio. All right, and our third and final step is to convert it to whatever it is that we're looking for. All right, so here we're looking for grams of water. All right, so that means I'm going to have 1 mole of water on bottom. Let's see, we know that 2 hydrogen is 2.016, oxygen is 15.999. So 15.999 plus 2.016 should be 18.015 for the molar mass for water. Okay. Now, when we're plugging this in, or this is stoichiometry, and let me go ahead and write the third step is to solve for what you're looking for. Okay, so 3 steps stoichiometry, and that's what we do. Okay, convert it to moles, use our mole ratio, convert it to what, or solve for what you're looking for. Okay, we're gonna treat this the same way like we did with moles. Okay, if the number was on top, do you remember what we did? We multiplied if it was on top, and what do we do if the number was on bottom? We divided. Okay, so we're gonna be doing the same thing here. All right, so let me scoot this up. Have it so you can see my calculator screen. Okay, so we have 36.95, and then we're going to divide it by 2.016. And then for the mole ratio, we multiply what's on top, so times 2, divided by what's on bottom, divided by 2. It won't always be the same number. All right, and then we have 18.015 on top, so we're going to multiply. All right, so this is going to give me 330.2 grams. All right, I just rounded to 1 decimal place. But as long as your answers are really close to mine, then you're definitely on the right track. With this, everybody's periodic tables are a little bit different, and we're not being super picky on sig figs. So as long as you're like, if you got 330 or 330.5, like consider it done. Like consider that you did it right. Okay. But again, this is working out stoichiometry problems. Okay, so what I want you guys to do is take your notes, flip it to the back. All right, here's the recipe, the equation for water. All right, now I want you to go ahead and write these 2 down. We're gonna do 2 more stoichiometry problems together, just to make sure that we're on the right track, because this will get us a good foundation for tomorrow. All right, so go ahead and write these 2 down. All right, if you're still writing them down, just pause the video, but I'm gonna go ahead and get started. All right, so again, we're always gonna start with what we're given. So here we're given 102 liters of oxygen. Draw my long line. All right, and it's wanting to figure out how many molecules of water that is. So let's recap with our rules. All right, so 1 was to convert to moles, 2 is the mole ratio. Oh, you can go ahead and get started on the stuff. All right, and then 3 was to solve the problem. Okay, so those were our 3 rules. Let's get this over a little bit. All right, so first step was convert it to moles. So if we have liters, what number do we use with liters? 22.4. Okay, so 22.4 liters of oxygen. And this is for every 1 mole of oxygen. Okay, so I've converted it to moles. Next is my mole ratio, right? Remember that the mole ratio is looking for over given. Okay, so we're looking for water, so it's 2 moles of water. We were given oxygen, and there's not a coefficient, so we're going to say 1 mole of oxygen. All right, so mole ratio, check. Solve problem, so it's looking for molecules of water. Do you remember what number we use with molecules? Avogadro's number. Okay, so 6.02 E23. And I write it down like I put it in the calculator. And then molecules is abbreviated with MLC. This is for H2O. And that equals 1 mole of H2O. Now, something that I didn't do on the last problem, but I should have done, okay, is to make sure that all of my units cancel out. So that way I know I have everything in the right place. So here we have liters of oxygen, liters of oxygen. Okay, moles of oxygen, those cancel each other out because they're diagonal. Moles of water, moles of water. And that leaves us with molecules of water. So I know I'm on the right track. All right, and what do we say we do to the numbers on top? We multiply. And what do we do with the numbers on bottom? Yeah, we divide. Okay, so when I put this one into the calculator, I get 102 divided by 22.4 times 2 times 6.02 E23. All right, so I get, we'll say 5.5 times 10 to the 24th. Because remember, if it says E24, that means times 10 to the 24th. Okay, now there's a lot of numbers. I don't want you guys to stress out if you're doing them like the dividing and multiplying in the right order. Because like here, I went left to right, dividing and multiplying where I needed to. But I could have done 102, and then I could have said times 2 times 6.02 E23, and then divided by 22.4 in the end, and I still get the same number. Okay, so as long as you're multiplying the correct numbers and dividing the correct numbers, you should be getting it correctly. Okay, again, when you have numbers with exponents in it, make sure you're using the e function on your calculator or like on your phone calculator, but the e function is really important. Okay, if you're starting to feel like you're getting the hang of this, go ahead and see how far you can get on this last problem. Pause the video, go for it. Okay, if you want to watch me work through the problem one more time, then here we go. Let's do it together. All right, so we have 7.15 times 10 to the 24th molecules of water, and it's wanting to know how many grams of hydrogen that is. Okay, so we start with what we're given. 7.15 E24. molecules of H2O. Okay, remember MLC is the abbreviation for molecules, and this is talking about water. Step 1 is the convert to moles. Okay, so 1 mole of water for every 6.02 E23 molecules of water. Since it's molecules, we're using Avogadro's number. Okay, and so now we've converted it to moles. So now we're at the mole ratio. Remember, it's looking for over given. So I'm looking for hydrogen, so moles of hydrogen. I'm given water, so moles of water. When we look at the balanced equation, it's 2 moles of hydrogen for every 2 moles of water. So it's this 2 over 2. All right, so now we have our mole ratio. And then this is asking for grams of hydrogen. Okay, so for every 1 mole of hydrogen, we have grams. See, remember hydrogen's 1.008 and there's 2 of them. So 2.016 grams of hydrogen. All right. When we're putting in the calculator, numbers on bottom we divide, numbers on top we multiply. And again, it doesn't matter what order you do it in, you should get the correct order. I prefer going left to right. Some people prefer doing top and then dividing by the bottom. Whatever you want to do. Okay, so let's move this up again so you can see the screen as I do it. All right, so 7.15 E24 divided by 6.02 E23 times 2 divided by 2 times 2.016. All right, so this is, we'll say 23.9. All right, so that's stoichiometry. This is what we're going to be working on between now and spring break. Okay, and we're just going to get our skills stronger and stronger to where we're super confident in this, because again, this is one of the major points in chemistry. Yeah, ask your teacher if you have questions on this. If math isn't your strong suit and you're getting stuck, you're not going to get any better by being quiet. Talk to your teacher. Okay, make sure that you do the knowledge check questions afterwards. But other than that, you guys have a great day. All right, bye.